Hey guys, in this video I'm going to show you how you can turn your Raspberry Pi into a NAS server using a simple plug-and-play USB SSD. We're going to do this by mounting the SSD to the Raspberry Pi's file system and then sharing it out to the network using the Samba utility. This is the simplest way to turn your Raspberry Pi into a NAS system. There are other options for turning a Raspberry Pi into a NAS, like installing openmedia Vault, but for this video we're going to stick with Samba because it's the simplest way to do it. So let's get started. Alright, so we're going to jump right into it. I have an SSH session to my Raspberry Pi, and I'm going to start off with the command ls_usb. Now, this command is used by Linux to display the information about USB buses and all the devices connected to them. Now, I don't currently have my USB plugged in, so let me plug it in and rerun the command. Alright, my USB is now plugged in, and now when I rerun the command ls_usb-t, I can see that a new device has shown up. And this is my external SSD. I can tell because it says the class is mass storage, and the driver is UAS, which stands for USB Attached SCSI, and basically this is a USB storage protocol that's much faster. It's only available for USB 3. Now if you're following along and you find that your driver is not UAS, that's fine. Everything in this video will still work for you. You might just not see as fast read or write speeds. Alright, so moving on, we are going to use the utility fdisk. And this is a utility used for disk partitioning, but we're just going to use it for informational purposes to have a look at how the partitions are set up on our SSD. And here we can see the disk, and then at the very bottom we can see the partitions within the disk. So it looks like this drive is already set up with an NTFS/exFAT partition, so that's good. We won't need to partition this drive because it's already partitioned for us. Now, the next thing to note here is on the left-hand side where it says device, and this is the actual file path to where that drive is located. And you can actually see the drive at this path if you do ls on the /dev directory. And this is just sort of the basics of the Linux file system. All devices in Linux have a file associated with them, and all those files live in the /dev folder. Alright, so moving forward, the next thing we need to do is create a mount point within the file system and then mount that device onto the file system. So this is very simple to do. First thing we need to do is create a new folder. So I'm going to do a makedir. I'm going to do a sudo makedir. And I'm going to say /media. And then I'm going to call this USB SSD. And this is just a directory within my file system. And the next thing I'm going to do is mount my device onto the file system. So just to check the device name again, I'm going to do an fdisk. And I actually need to do a /l here, and let's run this as root. So we'll try that again, and this is the device that I'm interested in. And I actually want to grab this into my clipboard. And I'm going to say mount, and I'm going to paste that here, and then I'm going to go /media/USB SSD. This is the directory that I just created. And it's going to tell me that only root can do that, so I'm going to do sudo again, and there you can see that it has mounted. Now a few of you may run into an error, and that's because the Raspbian OS does not support the exFAT file system by default. If you want to mount an SSD that is using the exFAT file format, you're going to need to install a few utilities. I'm going to run that command again just to show everyone here, but it's basically sudo apt install exFAT-fuse and then exFAT-utils. It's all updated to the latest version, but if you're on a default install of the Raspbian OS, then you probably need to install this. Anyways, now that it's mounted, we should be able to see the file system here, so let me go ahead and clear the screen. And now I'm going to head on over to that folder structure that we created. And when I do an ls, I can see there's some files on this file system. I did create a file on here before, and I can see that it transferred over, and I can create new files if I wanted to. And go to my Linux file, and we can see that the new file is on the SSD. Perfect. Now our Raspberry Pi has access to the SSD. However, mounting the SSD like this is not what we want to do for the long term, because if we reboot, our configuration is not going to be persistent. We would have to remount it again. What we need to do is edit the fstab folder and create a permanent mount point. So to start us off, I'm going to unmount the SSD that we just mounted. So I'm going to do that by doing a sudo unmount, and then I'm going to specify the device, which was dev/sda1, and it's actually umount, not unmount. And it's busy because I'm in it, so I'll go down a directory and I'll run that command again, and when we go into that directory, we will see that there's no files in it because we've unmounted the device. So let's go ahead now and have a look at our fstab folder. The fstab folder is located in etc/fstab, and let's cat it out to have a look at our current mount points. And we can see that we just have the basics in there. Nothing has been set up. So I'm going to go ahead and clear the screen. And then I'm going to open this folder using the nano utility. And I'll go ect/fstab. And I'm going to create a new line here. And I'm just going to copy and paste. And this should be enough. So we have the device, we have the mount point, we have the file system, and some additional parameters that we won't worry about right now. But let's go ahead and do a Control-O, and this will write out to the fstab file, and I'm going to exit out. And now I'm going to run the command sudo mount-a. And this is basically going to read the fstab file and look for new mount points and mount anything that hasn't been mounted yet. We can see that we got some feedback here, and now if we do an ls, we don't seem to see anything. So let me go back a directory and come back into it, and I'll do another ls. And there my file's at. So we found the files, and this is actually going to be persistent through a reboot. And that's because during a boot, Linux actually looks at that fstab folder and mounts any devices within it. Now, one thing I want to show before we move into the installation of the NAS software is we should actually make one more change to our fstab file, and it's to reference the device by a unique ID instead of using the common name of just /SDA or SDA1, and that's because the mount point could change at some point. So what we should do is do an ls-l/dev disk and then by UUID/star. And this is going to give the unique identifier of each of the locations. So since we're interested in SDA1, we can see that this is the unique identifier. So let's go ahead and edit our fstab file using that unique identifier. But before we do that, I'm going to unmount my drive again. So I'll just do a sudo umount dev/sda1. And I need to get out of my directory again. And now it lets me. Now let's go ahead and head into our fstab file. Alright, so we're in our fstab file, and I'm going to actually just replace this with the line that's in my clipboard, and I'm going to write this out and exit, and I'm just going to do a sudo mount-a again, and this is going to remount all the stuff in fstab. We get some output here that shows that the exFAT file system was mounted. So if we go back into our USB-SSD, we can see the files. And now we can move on with the setup of Samba. Alright, so if you're unfamiliar with what Samba is, it's basically a suite of services and programs on Linux with helps with the interoperability with Windows systems. In our case, it's going to let us create a share on our Linux Raspberry Pi that our Windows client will be able to access. Alright, so I'm going to get started with the installation of Samba here, and that's going to be sudo apt install Samba, and then Samba common -bin. And then I'm going to go ahead and hit Y for yes to install, and it's just going to run through the installation of Samba. So this is asking about if we should set up wins with DHCP. I don't have any win settings in my DHCP, so I'm just going to hit no. You can hit no as well. Alright, so the Samba has completed installation. Okay, so the next few steps are very simple. The first thing I'm going to do is hop into that directory where our SSD is mounted. So I'll go to /media/USB SSD, and I'm going to create a new folder called shared, and then I'm going to go into that folder, and I'm just going to do touch my file.txt, and this is just to confirm that when I connect on my Windows machine I can see my file. So on my Raspberry Pi I can see the file exists there. The next thing I want to do is configure Samba. So to do that I'm going to go sudo nano/etc/samba/smb.conf, and this is the Samba configuration. So now that I'm in here, I'm going to scroll down to the bottom, and I'm going to paste in a configuration here. And basically, this is going to be the share name. So we're going to put in the IP address or the host name of the Raspberry Pi, followed by this share name. And this share name is going to be sharing this path on the local file system, which is the directory that we just created. And these settings are just for the permissions. If you want to modify those or anything, that's fine. Just look up the documentation on how you should set them. So this should be good. I'm going to save this. The next thing we need to do is add our current user to Samba. So we do that by going sudo smb pass wd -a pi. And if you're using a different username, you would put that here, but I'm using Pi, so I want to use that. And now it's asking for my SMB password, so I'm just going to set it the same as my account name. So I just set it the same as my password. The next thing we want to do is restart Samba, so we can do that with sudo system control restart SMBD, and that went ahead and restarted the Samba service. Next thing we want to do is actually connect to our Samba service using our Windows client. So I'm just going to do a quick hostname -i, and this is the IP address that I want to connect to, so I'll get that in my clipboard. And I'm going to pull up a file explorer here on my Windows box, and I'm just going to go // put in the IP, followed by pi share. And then I'll hit enter, and it's letting me in there. Now it might prompt you for user credentials. If it does, put in the user credentials for that Samba user that you created. If you want it so it doesn't prompt you for credentials, just make your credentials the same as it is in Windows. So that's it. You can see that we can access the file and everything, and we can even write out to it here from Windows. And if we do an ls on our Raspberry Pi, we can see that it sees the new files. So that's how easy it is to set up an external hard drive and turn your Raspberry Pi into a simple file share. I hope this video was informative, and remember, if the women don't find you handsome, they should at least find you handy. Good day, everyone.